Welcome back, and we're going to now see in this fourth and last chapter of the day how to work with materials and how to work with inputs. So again, we are still the same guys, and we are still the Davids, and we're still from France, and we love 3D. So this is the last one. We're going to now understand what material is. So David's going to explain us what material is, what a shader is inside Babylon.js, and we're going to work on inputs. So basically, this is the two part of the agenda, but let's start by doing a little teasing of what we're going to see together. So on my side, I've been working on building this simple scene. So you can see that I can move using the mouse and keyboard as usual, but maybe as you can see on my camera, I've got this beautiful Xbox One gamepad, so I can use it in my engine, in my game. So I'm pressing A. And now you can see on my screen that I can move using my gamepad in the 3D environment using some cubes we've seen in the previous chapter. And now we need to understand how to put this beautiful texture on the floor and the wall. And I still have the collision engine enabled. Okay, so we're going to learn how to build that. And on David's machine, we're going to see another thing. So
absolutely. So here is the sample we will construct together. So it's about sphere with a lot of different materials that we will see together. So two parts. One that I will present about materials, and the second part will be presented by David about working with inputs. So let's go for the very first part. Section 1, materials. We saw together how to create a scene, let's say, with a camera, lights, and meshes. These meshes are right now pretty awful, let's say, just one color. Yes, we can play with the color of the light, but all the objects we created are just plain, just one color. Here enter the standard material. So the standard material is a tool for you that we design into Babylon.js to hide all the shaders complexity. We really want to use this only object to let you work with shaders without having to deal with buffers, performance, optimization, communication between CPU and GPU. Everything will be hid for you by the standard material. Basically, the standard material supports a lot of features. We will see almost all of them. We have some kind words here like diffuse, specular, bump, reflection. Everything will be easy to use thanks to the standard material. For this specific kind of things, I think the only way to understand how things are working is to do a demonstration. So let's move to my Visual Studio. In my Visual Studio right here, I have a pretty simple scene. As always, I reference Babylon.js. I define the HTML and the body so that there is no padding, no margin, just full screen canvas. And my canvas does not use touch, and let me handle that for it. And I have full screen canvas. Almost the same story. Then I have my canvas, and that's pretty much it about DOM element. Then, as we saw with David, we get the canvas, we create the engine. This time I want anti-aliasing to have some really cool rendering. I create a scene, and I create a free camera. You did that before, so nothing new here. I define the target of my camera. Remember, a camera is basically a position and somewhere to look at. So this is exactly what this specific function is doing. And I attach my camera to the canvas. So each time I move the mouse or I touch the screen, then the camera will know how to handle the inputs. Finally, I add an hemispheric light, so we will have a global illumination of the scene. Then I create a simple sphere. I put this sphere just in Y at 1, so it's not barely on the ground, it's just a bit floating on top of the ground. And I create my ground, which is a big ground, as you can see, 100 by 100. I just add my render loop, and something a bit new here that I wanted to show you. If you want to keep the rendering at the regular resolution even when you resize the screen. You just have to handle the resize event on the Windows object and just call engine.resize. That's everything. Everything will be done for you by Babylon.js itself. So let's view this specific scene. A big white ground, yeah, and a sphere, a gray sphere. We will work on that. So let me first introduce something really powerful, the standard material itself. So I just have to create my material, which is a new Babylon.standard material. And this standard material needs two things. It needs a name, so the name will be Matt, for instance, and the scene itself. Okay? Then, if I want to apply this material to a specific object, I just have to pick my object, so here my sphere. Let's say that the material is equal to Matt. That's it. And then I can play with my material. For instance, I can say, hey, this material will have a diffuse color. So what's the diffuse?
Yep.
The diffuse is the color of the object when a light is lighting it. Okay, so if I have a white light and a red material, then my object will be red. Okay? If I have no light and a red material, then the object will be black. Absolutely, because there is no light. The diffuse is based on lighting. So let's say I want something like, let's say red, because I love red. So let's use this function without the typo. And that's it. Yeah, I have a red sphere.
Beautiful.
Absolutely. We can play a little bit with that. What I can do is create a group of spheres. So I will play with different material on different spheres, if okay with you. So for instance, let's say I will create a variable, which is an angle. What I want to do is put my sphere on a circle, okay, so I can see them. And I want to create, let's say, 10 spheres. So I create an index. While this index is not 10, I just go through my index, okay? Here, what I want to say, I want to create a sphere. So this sphere will be like this one. Let me remove this one and put that here. Remove that. Okay. So it won't be sphere 1. It will be sphere, and I just had index to be sure that I have the right name. Pretty simple, right?
Yes.
Then I will put my sphere. So what I want to say is I don't want to be into the ground, but just a bit upper. Yep. So let's say it's 1. Remember, the radius of my sphere, the diameter, of my sphere is 2. So the radius is 1. So if I use a y equal to 1, then I'm just on top of the ground.
But, yes, the bottom part of the sphere is just touching the
ground.
ground.
Absolutely. Okay. And then I will use the sphere equation. So you don't have to know it, but it's pretty easy, by the way. So x will be equal to, let's say, 10 multiplied by math dot sin the angle. So the equation of a sphere is exactly that. Sin in one side and cos in the other side. Just by doing that, I will create 10 spheres, okay? And this sphere will be just into a circle. I just have to add a new value to the angle. So the perimeter of a sphere is p. And because I have 10 spheres, yeah, it's 2 multiplied by p. So I divide by 10, and I multiply here 2. So 2 multiplied by p is the perimeter of a circle, and divided by the number of spheres, I got my result. Sounds good?
Yep.
Let's try that. And I have an exception. I love that, yes, because I just forgot to remove that here. For now, I just want to create my sphere. Okay, sounds good. And I can see I have sphere on a circle.
It looks like a clock, but not with all the...
Yeah, it's a clock, but with only 10 hours.
Yes.
That's strange. So right now, what I want to say is I want to create a specific material for every sphere, okay? So let's create on my loop a new material each time. So is equal to new Babylon.standard material, and the name will be mat plus index, and the scene will be scene. Then obviously the current sphere will have this material, okay? And that's good. And here what I want to do is a switch based on the index so that I can create for you guys different options. First option, 0. In this case, let's make it simple and let's add break here. So let's make it simple and just define the diffuse color, okay? So the very first sphere will just have, like we did before.
You want to have some red diffuse color?
Just red diffuse color, absolutely. Nothing else. And it's color 3 here, dot red. But let's have a look quickly at that. Okay, just one red sphere, cool. But I don't want that. That is a specular. That is the impact of the light on the surface, okay? Each time you have a light, where the light is perfectly perpendicular to the surface, you will have this specular effect. It's like in the real world. I don't want that for this material. I want what we can call a mate material. So no specular at all.
So you can control how the light
exactly
apply to the mesh. Okay.
Yes, and thanks to this material itself, I just have to say, hey, I just don't want a specular color. No color means, when you are in the world of color, black. So I have a perfectly made red sphere.
Okay.
And as you can see with the following one, there is a specular on this one and not in this one. And this is what I want. Okay, moving to the following sphere. So, following sphere, let's say this time we want something like red and specular, okay? So what we can do is just take this, and instead of using black, I want white, which is the default value.
Okay.
So no specular, specular. Red diffuse, we're good. And we can see it's diffuse. Why? Because there is a dark area right here, based on the fact that the light cannot reach this part of the object, right? Moving forward, let's take K2. K is 2, and unpack K2. All right, so here what I want to do is to play with a new feature of the standard material itself, which is the emissive color. The emissive color is the color of the object without a light. It's the color emitted by the object itself when there is no light. So,
which is strange.
It's strange, but let's think about, it's hard to decorate things, but let's think about the sun itself. The sun itself emits its own color. We can consider that the sun is a light, but that's not easy to explain in a real world. So emissive color here can be, for instance, let's say red. And in this case, I just don't want diffuse, and I don't want specular. Only the emissive color itself. And let's have a look. All the part of the object itself will shine a red color.
So you can remove the light, for instance?
If I can remove the light, for instance. Don't add a light here. And as you can see, the only object remaining is the one with an emissive color. Because without a light, he still has a color. He still has a color.
So he's emitting his own color without any light. Okay.
Absolutely. But just for him. It's not a light source. It's just for him. All right. Then let's take the following one, and we will still add new funky effect. Remember, we are still using the standard material itself. And we are just playing with shaders inside this standard material, but BabylonJS is doing everything for you. It's compiling the right shaders, removing everything that is not required, just compiling the most efficient shaders for every single case.
So you have a single object, which is a standard material, and controlling it using the various options.
Yep.
And there is a lot of things being done.
Yep. Behind the scene, there are a lot of different optimization, and there are a lot of different shaders. Here, I can say that if I create 3 different option set like this, I know that there is 3 different shaders. So we just use each time the right one to be efficient.
Okay.
So moving to case 3. In case 3, I just want to use not a diffuse color this time, but a texture. So instead of a plain color, I want a texture.
Which is far better.
Which is far better, I agree with you. So in my project, it's here. I have some texture, and the very first one will be this one, the wood.jpg. So it's just a wood texture. And instead of using texture color, diffuse color, I will use diffuse texture. And I just ask Babylon to create for me a new texture. So creating a texture for me means loading it from somewhere, sending everything and creating buffers for you, and sending everything to the GPU. And be able to switch when the object is used and when the object is not used. So everything will be handled for you by the standard material. So I just have to create a texture and say, hey, I just want the wood.jpg file. Here is the scene. That's it. I have nothing else to do if I want textures. Ta-da!
Great.
So as you can see, we can mix effects because I have specular. So if I don't want specular, I just have to say, hey, specular equal black. That's it. But I can say, OK, I have a texture. That's pretty cool. And this texture is a diffuse texture. So it used the light to compute the real color. So here, it's darkened than here.
OK.
OK?
It's mixing the effects.
Everything for you. Each time a new shader is compiled with just what you need. So let's move to the next sphere. In this case, what I want to do is still have a texture, but I will play with how the texture is applied on the object. I want to have more, I want to feel more like hardwood, I mean, something more dense when I use my texture. So I can do exactly that. And with the texture itself, I can play with some kind of multiplicators effect. The first one is U-scale. Remember U and V? So, for instance, right now the texture is applied on the sphere so that all the texture is perfectly mapped onto this sphere. But if I can play with the scale itself, so I want my texture to be applied many times on the same object.
To repeat it. No?
Yeah, it's a way of repeating exactly on U and obviously on V. By just doing that, look. This time, we feel the hardwood here. And look here, it's more precise. We applied the same texture many more times.
OK, so we have more resolution in a way.
Yeah.
Okay.
And it repeats more time. Obviously, as you can see, the texture is repeated 5 times.
OK.
On the same object. Next case. Case 5. This time, what I want to do is to play with a different kind of texture. So let's remove that. I keep my diffuse texture here, but instead of using a JPEG, I will use this texture. The white part of this texture is transparent. And BabylonJS know how to handle that. So if I'm using here 3.png, PNG why? Because there is alpha. There is no alpha in JPEG. Then I can say to BabylonJS, hey, beware, there is alpha.
So you need to remove the white, for instance, and to show the transparent color.
Yeah, in fact,
if you don't say use alpha,
it will just be white. I can do that. Look, if I just do that, I have here, where is my object? Oh, just beneath me. Okay, as you can see, where there is a white, it's just black.
Okay.
Because there is no white in the texture, there is pure alpha. But what I want to say, no, I don't want the black effect here. I want nothing here.
You want to look through the object.
Absolutely. So just say, hey, there is alpha in this specific texture. Let's do that again. and look, far better, right?
Yes.
So if I'm moving here, I can see other objects through the foliage, for instance. So it's far easy for you as a developer to just create a simple quad, apply this texture on it, and you have a tree.
Okay. It's where the most of the trees are being made.
Yeah, if you want to create geometry for this specific complex object, it's
Yeah.
too complicated to create a tree. But just having texture that simulate with this effect.
And even if they are far away in the 3D scene, nobody can make the difference between a false tree and
a
true
real tree, absolutely.
Yeah. Okay.
We can continue to play with this effect on the case 6. What we can do is just say, okay, the diffuse texture will be this one. Okay, this will be alpha. And let's mix things up. I want also to add some green color on top of it. So we will have both diffuse and emissive together. That's really interesting. And, oops, sorry, I forgot matte here. And I would also like to avoid removing back faces. We will see that. Just by saying that, I have interesting things. So, as you can see here, I can see the back face. Sounds like there is no back face, because this is an optimization which is by default. When I display this sphere, I don't see the back faces. Mm-hmm. So there is no need to render them. When using PNG here, obviously, it should be interesting to see back faces. That's why we have the specific parameter I'm using just here. And as you can see, I see the back faces where the texture is applied. And because I'm using some emissive color, the object
is more green.
Even when there is no light. So on the bottom of it, the object is greener than the previous one, just because I'm playing with a diffuse texture with no backface culling and an emissive color. And it's just one line of code each time. I want that with that. It's like a painter. You mix things up, and at the end, the shader is created for you by Babylon.js.
Okay.
So moving to case 7.
So what you will do now?
We will go to something more interesting, I think. So let's play with a diffuse color, and this time I will keep a plain color. Color 3 dot, and because we like it, purple.
Yeah.
Then let's introduce a new option, the bump. The bump is a really cool feature, mostly invented by some old 3D games like Doom 3 or things like that, where if you want to simulate a complex geometry, there is two ways. Create a complex geometry, which is not a good idea, or use the bump. The bump, and I will show you how it works, just add volume on top of your object. There is no real volume. In fact, the bump play with the light itself, changing a bit how the light is reflecting on top of the surface. By default, a surface is flat. So, for instance, if I'm going here, we can see that we cannot feel anything on top of my sphere. We can feel that the sphere is perfectly flat. Yeah. And I don't want something perfectly flat. I want to simulate volume. And to do that, I mean simulating and not really rendering.
Yeah.
Yep. We can use the bump. The bump is based on something really interesting. And I don't have it right here. Here. Okay. We can see this specific texture here. It's a normal map. A normal map is a texture where color does not define a color, but define an 8. You can see and feel that. We can feel that it's some kind of rocks and different pavement in here.
And most of the floors and walls that are being made in the games are using the bump mapping.
Yes, because you can simulate how the bricks looks like without having to deal with real bricks. I mean, which is really interesting.
So in the real world, this is completely flat geometries, but when you're looking at it, thanks to the lightning effect, you think that you have some bit of bump. But
Doom 3 was really one of the most successful games that use these specific techniques. So if you want to create Doom, the next version, you can just say, hey, I want a bump texture, and this bump texture will be a new texture like any other. So in this time, I will like to use normalmap.jpg. Okay, and that's it. As you can see right now, this is a purple object, but clearly we feel that there is a volume.
Stay calm.
I love that. So look, sounds like there is some not flat surface, right?
But if you were displaying the face and the wireframing, it would be completely flat.
It's absolutely flat. This is exactly the same object. But
so this is thanks to the pixel shader.
Yeah, the pixel shader here, instead of applying a perfectly round specular, for instance, just apply it sometime and sometimes it doesn't apply it, just according to the bump texture,
and
the normal map.
Okay.
So we feel like there is a surface which is not flat.
Okay.
And as you can see, that's pretty interesting. Really, we can create here some kind of...
I know that you can spend hours watching
absolutely.
beautiful purple bump sphere.
I love that. So next case will be case 8. And just for the 8, what I want to do is play with another kind of extremely powerful texture. Let's take some wood this time. You see, I'm like a painter. I pick a bit of that and a bit of that, and I mix things up. And this time I will use the reflection texture. The reflection texture can be used to simulate reflection. Right. How to do that? This time we will use a really strange object, which is the cube texture. A cube texture is made of 6 textures. And we can think about a cube where each face is a different texture. And using this cube, we can have a view on all the environment, because every kind of the environment is mapped on the face of our cube. Mm-hmm. Okay? So let's have a look in here, for instance. I have here 6 textures, each of them representing a view into a specific environment. This is the SPLit demo we are using in here. So when I'm saying, hey, use this specific one, use this specific cube texture as a reflection texture, and just, so the name is ref cube, you just have to specify the very first part here, ref cube. Everything else is deduced for you. Just with that, look, sounds like this one is made of glass.
Okay, try to reflect the texture that should be in a cube, in a global cube.
Yeah.
Okay.
So when I rotate around, we feel that this is weird because the environment is not the right one here, obviously. But if I apply this same cube to a skybox that we will talk about later, next time, by the way, then it will be just impressive because we will feel that there is a reflection, a real-life reflection, just because we are using a cube texture.
So we try to fake the real environment.
3D is like a movie in the cinema. We spend all our time faking the reality because we don't have
enough power
to just create the reality. Okay, and just the latest one, because this is also interesting. You talk about wireframe. Obviously, we support wireframe. You can just ask, hey, just render as a wireframe, as a way to debug or perhaps just put the focus on a specific object. So here they are. We have 10 different shaders all working together. And
maybe you can zoom a little bit on the wireframe one, just to.
Sure. Let's move.
You can zoom when you.
Yeah. Yep.
Okay, so we now see the triangle again.
We see we can see the triangle and we can see the tessellation in here because we can count the number of triangles if we want. Okay, bump, reflection, opacity, diffuse, specular. They are all in here, and you can just play with them. Okay?
Okay.
So moving next. Sorry. After that, what I want to talk about is the multi-material. Multi-material is a way to just have one object, one single object, and apply different material on different parts of this specific object. Think about a tree. A tree is made of a trunk and a foliage, all right? So you can apply a specific material for the trunk, a specific material for the foliage, and you're done. And
you've got only one object.
And you can you get just one object. So you can move it around without having to deal with 2 objects together. That's a really interesting way. How to do that? I have a sample for that. So blah, 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 we have everything we did before. I just want to create a new big sphere, this time with 10 as the diameter. I put that at this specific position. Oh, and I forgot to mention something before. Sorry about that. Interesting usage of the standard material, and I forgot this one, sorry guys, is using the reflection texture, but not based on a cube, but on the real-time environment rendering tool. We have an object called the mirror texture. The mirror texture uses a parameter which is the size of the texture, so it's 1000 by 1000, okay? This mirror texture needs a plane to define where is the plane of the mirror itself, and we can specify the level. I mean, just 60% of the reflection texture will be used in the global aggregation, okay? Then I put that on the ground, and as you can see here, each time I create a sphere, I add this sphere to my material reflection texture render list.
So you ask this object to be part of the real-time mirror that's going to be computed?
Exactly. So just keeping everything else in the same way. Look.
Okay, we've got some real-time reflection then. Okay.
Yep, we got some real-time reflection yet. So right now when I move, we can see that the plane feels like a mirror. And it's a real-time mirror because I added this specific object here. And I will get back to it quickly, but as you can see, things are moving and the reflection change live.
So if you were moving the sphere, it will update also the mirror?
Absolutely. Just a quick view on this specific object. I added a new one here, and I can use a video texture. So you can use JPEG, PNG, obviously, but you can also use MP4 textures, live moving, and they will be applied on your object. So it's really powerful to create, for instance, a TV or some kind of screen that you want to have live, then you can just play with that. Going back to my multimat, what I want to do is create, as I mentioned, a big sphere. So I add my big sphere to the reflection texture of my mirror material. And to create a multi-material is pretty easy. You just create a multi-material object, and there is a sub-materials property where you have just to push all the material you want to reference. And the big sphere itself can now be changed with interesting properties. By default, there is no submesh, so the mesh will be affected to only one material. If I want to define submeshes, if I want to define that this part of the mesh will be affected to this material and this part of the mesh will be affected to this material, I just have to play here with the submeshes. So how it works. I get how many vertices there is. I get how many indices there is. And then, let's say, I will work by bunch of 3030 vertices. So just bunch of vertices for every group. And each time I do that, I just create a submesh and I say, hey, move to this current index. This is the offset. And this one will receive this index.
So you are basically cutting the sphere in 10.
The result will be easier to understand. Look, I have a big sphere with a reflection. And the top of it is our specular red, no specular, then the wood itself, and I played with the wood. I will show you how to just animate the position. Then we have opacity with emissive, etc., the bump, and somewhere in here there will the reflection, as you can see, and here this is the video, but this is the black part of the video. Just one object, but a lot of material on it.
So you are combining all effects on a single mesh.
Absolutely. Here. So I can just move my big sphere as I want, and things will continue to work as only one mesh.
He's pretty proud of the output, but I think this is really ugly. But
I agree, but I'm a developer, you know. I don't create really beautiful things. I just create interesting
things.
Some
mixing effects couldn't be a great idea if you're not a 3D artist.
Absolutely, yeah. You have to be a developer to understand the beauty of that thing. And as you mentioned before, I can use a really interesting function in here. I can ask the scene to call this function before every frame. Okay. And in this function, I get the default 4, and I play with diffuse texture. You know, this is the wood one. And I play with the offset. So this time it's not the scaling of the texture, but the position of the texture. And you see that
it's cycling.
Yeah, the texture is cycling. And you ask me, let's say, what can you do if the object is moving? Let's move here on this x-axis. So every frame, the sphere will move on the x-axis.
And we can
it's
see
even more beautiful than before, I think. And as you can see,
it's in real time for the mirror, so everything is moving. So
yeah, okay. Everything is moving. Texture is applied just on every single segment of my sphere. And playing with the offset, I can do that, which is like the artwood is moving.
Yeah. Like a fountain made
Like
of
a
wood.
fountain, yeah, but made by a developer, which is just so ugly. The very last part I want to talk about is dynamic texture. We saw that we can use video, we can use plain texture, colors, obviously. We can add some special effect like the bump, the reflection, but we can also go further than that because you can also use the Canvas API, the 2D Canvas API, to render into a texture. So for instance, if you want to write text or add some really dynamic content, you just have to play not with the Babylon.texture, but with the Babylon.dynamic texture. Let me show you how this works. Here, same story, I have my mirror, I have my sphere, blah, blah, blah. And at the very end, just here, I add a box. This box will be on top of the big sphere. I'm pretty proud of the construction of my scene, to be honest with you. I have a standard material. This standard material will be applied to my box.
Okay,
Nothing special.
so we know that now.
Oh yeah, we know that. The diffuse texture will be a dynamic texture. The dynamic texture is here. It's a texture made by this size, so 512 by 512. This texture will generate alpha, no problem about that. And what I can do now is, as before, register a new function before render. So this function will be called on every frame. And the dynamic texture, like a canvas, can get a context.
So this is a Canvas 2D APIs?
Absolutely, it's exactly the Canvas 2D API. This context here are exactly the same API as a 2D Canvas. So you can call clear rect, fill style, fill text, draw arc, and things. Everything that you know about the 2D Canvas work here.
Okay.
Okay. So here, what I do, I just clear my texture. I define a font. I measure the size of my text, which is just a count, and this count go bigger on every frame. And I fill style to white, so the text will be written using white, and I just ask to write my text at a specific size, at a specific position. It's exactly pure 2D Canvas API. And because I call that before rendering my frame, this is diffuse texture, so it depends on the texture, on the light. So that's why on top it's white, and on the
side, yeah.
On the side, it's more gray.
So you can even mix 2D Canvas with the effects we've got.
Yeah, and you can generate, for instance, bump texture live, or play with your video.
Or creating procedural texture.
Yeah, if you want to create procedural textures like clouds or things like that, you can do whatever you want. So here is the big picture. All shaders all together, video, transparency, bump, reflection, everything working with a mirror.
What a beautiful scene.
Yeah, I'm proud of me. I'm an artist.
You should be.
So this is how the standard material is working. And I would like to give you the mic right now to talk about something a bit different, but also really interesting.
Yes, we're now going to see how to work with the various type of inputs. So you're going to see that it's fairly simple to use because we've been working hard to make it simple. So we've got various type of camera. So the first one, the free camera that we've been using up to now. But another one is a touch camera. So if you've got only one finger and you want to move the camera, you can do it using this touch camera. Another one is based on the accelerometer you've got, or the various sensor you may have on your Windows phone or tablets or various type of devices. So we're going to use a device orientation API to move the camera that way. You got the virtual joystick one. The idea is to move like inside the FPS or like a gamepad, but using a touch screen. So using your 2SEM, you can move the camera. We're going to see that. We've got an anaglyph camera is to simulate real 3D using some red and blue or green and red glasses when before the real 3D we had in the movies. And now we also have the Oculus, so we're pretty proud of that one. You're going to see how to activate that with using one line of code. So you've got to have an Oculus at home,
Obviously.
of course. And then finally the gamepad camera, and that you can use your favorite gamepad, so an Xbox controller, Xbox 360 or Xbox One is really good supported on Windows, and maybe other type of gamepad you may have at home if you've got the proper drivers. So let's see how to do that. So I've tried to build a scene. It's a bit much more beautiful maybe than yours. Maybe the people will be able to share what they're thinking about your scene and my scene on the current live
Please use
broadcast.
the chat to let us know which scene is the better.
Yeah, so I won't go too deep in my scene. My idea was to take a QR code. So I can find for a QR code image, for instance. And I was thinking that it would be great to create a 3D maze based on the QR code by just looking at where the black square were. So when there is a black square, I'm going to create a cube, okay? And I put that in the scene and let people moving inside that. So the idea is to create a maze using a QR code.
So you can wander around into a QR code.
Okay, so that's pretty what I want to do, is to move inside the QR code in 3D. So this was my idea, just to read that. And so I'm using a library over there that is helping you to create a QR code. So this is an open source library I've took. And then I'm creating the QR code based on the specific sentence. And I'm going to loop through all the various square. And I'm creating, a bit later, is a loop to create the maze. Okay, to create the maze, I need to set up different things. So the first thing is the ground. The ground, I'm using various type of textures, so the emissive texture, bump texture, specular texture. So, and I'm moving the U scale, V scale, as you've shown us in the past demonstration. I'm also using a free camera, checking the collision, and applying the gravity. Finally, what I'm doing is also putting some lights and putting some material on the wall using some bump texture to have some feeling about volume. And this is it. So when I'm doing that, if I'm pressing Ctrl F5, it's going to launch the website. I need to remember what was the URL. It is. I'm going to launch it. And by default, I will have a free camera, meaning that I can move inside my maze using my keyboard and my mouse, okay? I can go through the wall. You can see that when I'm moving down, I can see some slight changings on the floor because we're using some specular texture and bump textures. Same for the walls, and I can see that I've got some orange-like lights coming from the space. And you can move in the maze that way. Now let's say that I don't want to move anymore using the keyboard and the mouse, but I want to use another type of inputs. So this is pretty simple. We've tried to do everything using a single line of code every time. So let's say now you want to use the virtual joystick one, because this screen is touch. You just have to switch from free camera to virtual joystick camera, and then pressing F5. And now I can use my two fingers. So this is a big screen. This is very impressive to use it using touch. But you can see that on the left, I can control the movements and the rotation on the right. So I've tried to simply mimic what we have on the gamepad. Okay, we can have a touch camera using only one touch. So I won't show it to you because we have so many camera types. We've got also the device orientation. For that, I need a phone or a tablet. So we don't have one connected, but you can test it on your side if you've got a phone supporting that. We've got a very nice one, which is a gamepad camera. So you need to have a browser supporting it. So i11 in the dev channel got it. So Chrome, Firefox got it also. So pressing F5 now, you're going to see that I'm asking me to activate the gamepad using the A button. And now I can move using my gamepad. So no change in my code at all. Every time it's going to work as is. And let's try two other camera. I know that you love that one, the anaglyph one. So anaglyph free camera. It needs another parameters, this one, because it's based on the space between your eyes. So let's say that we've got a default value like this one. And now pressing F5. If you're wearing these all special glasses, you should maybe see in 3D now, in real 3D, using this kind of rendering. So it's very fun and very easy to use. But the best things to have, of course, is
the Oculus One.
The Oculus One. So the Oculus One, I have everything set up. So the only thing I need to change is say I want the Oculus. So let's search for Oculus. Oculus camera, and you know the way Oculus is working, it's a screen that's been divided in two parts, and you've got some lenses inside that, so you need to compute in a specific way how it's going to be rendered. So we are going to divide the screen in two and have some special effects for each of your eyes. And when you're going to move the head, the idea is to get the input via a specific driver we have on the website, so you can download it. And once you've done that, if I'm pressing F5, you can see that I've got the screen split, so you have to run that in full screen, of course. And when you will move your head, if you've got an Oculus, you will move right on left, and up and down. It will dynamically be updated in the engine without doing anything, and we are based on the device orientation APIs, so it can even work on making your own Oculus. If you've got your phone, you can try to trick our camera and use a classic phone. When you will move the phone that way, you will use a device orientation and make your own Oculus at home if you want to. So I've got a friend working on that. So here it is. As you can see, it's pretty simple to implement. Just one line of code. This is really the idea. And as soon as you take the control of the camera using the attached control, everything is being done for you. So very easy to use. So if we go back to the slide, we've got some online tutorial to help you. So the one on materials, so David has been explaining in detail how it's working. And if you want to check in detail how to create my 3D wonderful QR code maze, you can check my blog and you can click on the link. So it's going to conclude the whole day.
This day, yeah.
Yes.
Thank you very much, Guy. Feel free to use the chat to let us know what you think about this. There is a poll, so please use it so we know that we can come back for a new edition or not. Yes, also let us know if my code is far better than him.
Yeah. We will see a lot of cool things next week if you are joining us.
Yep.
So we'll use Blender and 3D Studio Max to build some beautiful scene.
And we will move from the purely developer world to developer and
designer.
Absolutely.
We will see how physics is working. We will see a lot of cool things, advanced effects like lens flare, particles, and a lot of cool things to build some beautiful games. So it will be next week. Hope to see you.
See you on October 23rd. Bye-bye, guys.
Bye.